We're heading up to the mountain in an L83 Gen 5 JK. This is a 4-door JK, 2013 I believe. It is a Pentastar JK. We got bump shifter in this one, and it's fully functional. So if I were to bring this back, well, let me put it back into drive. You can see we're in drive now. Bring it back into bump shift, we're in fourth. I can upshift, I can downshift, or I can just put it back into drive and let it be a full automatic. Let's talk about the cooling system. This Gen 5 has a computer-controlled cooling fan. It's being run by the Gen 5 computer. The Gen 5 computers control cooling temperature a little bit different than the others. We have set a target goal of 212 degrees into the ECM. So it is shooting for 212 degrees. That's its target goal. Doesn't really matter what load I'm under. Yes, there are modifiers that will change it, but essentially it's going to hover around 212 degrees, which is for the best efficiency, economy, etc. You don't want to run these LSs too cool. So we're taking this L83 Gen 5 6-speed up to the mountain. I think the Gen 5 5.3 is going to make an excellent choice for a JK because of its technology. It has continuous variable valve timing, direct injection, enhanced air fuel management, high compression on regular gasoline, a lot of qualities that you want in your Jeep. Having direct injection, a 6-speed transmission, and continuous variable valve timing means that this engine has a lot of torque off the line, so it can haul a heavy JK better than the Gen 4 5.3. The Gen 4 5.3 was an excellent engine, but the Gen 5 5.3 has added some more bottom end torque if you have a heavy JK, making it more appropriate for more applications. With the Gen 4 5.3, they work best in light JKs with smaller tires, and they make an excellent engine in that application. The Gen 5 5.3 I think is going to be more at home in heavier vehicles. You can see here we're still hovering about 210, 212 degrees. So the computer is controlling this fan not only based on coolant temperature, but transmission temperature and air conditioning pressure. It's a cool day out, so we don't have the air conditioning on, but it would if we had the air conditioning on. The Gen 5 motors have a lot of stuff going on. With air fuel management, that means they have air fuel management lifters and the lifter manifold assembly that has solenoids in it. So what this engine is about is technology. They're trying to maximize economy and performance through technology. The downside of that is we have a higher parts count. And just based on logic and math, the higher the parts count, the more chance there is of a failure. Do not rev up air fuel management lifters. You can't spin them up like an LS3 or a non-AFM engine. These engines are designed to make torque. The end of the world is 6,000 RPM. If you push it, you're probably going to crunch a lifter. But up to that red line, they put out tremendous torque. In fact, the L86, I believe, puts out over 350 foot-pounds of torque at 1,500 RPM. That's just off idle. And it carries that right through to the red line, having over 400 foot-pounds of torque. So what that means is it launches hard off the line, and it'll pull most of the high horsepower crate motors off the line, and they have to catch up. So at the end of the day, that torque and the flat torque curve over a wide range just outside of the red line. There is no peaky power band like there would be with a turbocharger or a traditional cammed engine. We've been installing Gen 5 engines now for just over a year. Just like when we pioneered the Gen 4 conversion in the JK, we had to pioneer the Gen 5. We're not using an over-the-counter GM controller or a 4-speed transmission. This is a engine performance system. We're running a 6-speed in this vehicle. However, we've got plenty of 8L90 8-speeds out there. We're running air fuel management. We're running, obviously, the direct injection, the continuous variable valve timing. We're running tap shift and or bump shift. So these conversions are fully networked. Our key interface in our Gen 5 swaps, which does clean up the wiring. Let me say something about the CAN interface. A lot of people think that you have to work with the CAN to do an engine conversion, and that's just not true. The reality is most of these signals are discrete, analog, digital. They get put onto the CAN for efficiencies for transmission throughout the network. For example, air conditioning. When you push a button to turn your air conditioning on, There is an analog signal or a multiplex signal that is put onto the can, and then that signal is sent out to the other modules. Same thing with the Prindle. You have an internal mode switch inside of these GM transmissions, and that is a mechanical switch that puts that signal out onto the can. So while the can has a lot of advantages as far as efficiency goes, everything with the can starts off the old-fashioned way. So there's many ways that you can do interfacing on these, and what the can offers is simplicity and some additional functionality. So while CAN technology does make the install easier and offers some functionality over the analog digital, it's not required. So what the CAN offers is more efficiency, less wire count. The flip side to the CAN is, while it does buy you efficiency and a lower wire count, so no matter how you integrate your conversion into your JK, whether it's CAN, discrete, analog digital, or you don't integrate, you just throw an LS in, I still feel the LSs, the LTs are the ultimate engine for a JK. They're lightweight, they're compact size, they're cool running, they're power delivery, excellent transmissions. I don't think there's anything else out that offers the whole package. When you combine that with our easy engine mounts, with our easy engine mounts and no fabrication install, that means no cutting, grinding, welding. Even on the electrical install, there's no cutting holes anywhere to route wires. This is actually a reversible swap, which means if you wanted to go back to your V6, you could. Why you would want to go back to your V6, I don't know, but it is a reversible swap. With our billet brackets laying the accessories out right back where they were, we're alleviating many hours of grief trying to set up a GM drive with interferences or make your own brackets. With our OE production harnesses being virtually plug and play, that means you're getting the safety of full power and ground distribution and the redundancy and failure modes that the manufacturer built in. With OE calibrations and software, that means you can use factory diagnostics for your particular engine. What we've really done is streamline the install to the point that you're doing an install at an OE level by using OE components, no fabrication, and that's big for a lot of my customers who do not allow cutting and grinding on the frame. What you're ending up with is basically a near production vehicle, which is the way the manufacturer would have done it if they had produced this vehicle.